Uh, Myself, Dr. S.V. Angodimat from CMDR. So, heartily welcome to you. Uh, Heartily welcome to all the participants. Today, we have a resource person, Ayse Ercumen, Associate Professor from North California State University. Heartily welcome to you, madam. Now, Dr. Naran Bellava will introduce Dr. Ayse Ercumen.
Dr. Ayse Ercumen is an associate professor in Department of Forestry and Environment Resource at North Carolina State University and core faculty in the Global Water Sanitation Hygiene cluster. And Dr. Ercumen expertise in the infection, disease, and environment epidemiology, and also she has over 10 years research expertise in the South Asia, including study site in Hubli, Dharwad. She has completed PhD research in based on the Hubli Dharwad 24% water supply system, and she has previously led health impact evaluation with the 4,000 household in the Hubli Dharwad to investigate the effect of the intermittent piped water supply on waterborne infections. She has also completed fellowship follow-up study with the 4,000 household in the Hubli Dharwad to study of the long-term health impact on intermediate water supply. Dr. Ercumen expertise is the leading the design, implementation, and data analysis of the large field studies with the extension laboratory. She has published more than 70 articles in the reputed journals. Again, welcome to Ayse once again. You can start.
Thank you. Thank you. Yeah, thank you for the introduction. I'm very happy to see faces from CMDR. I think it was almost 15 years ago that we launched our first research collaboration with CMDR to study 24/7 water supply. And it holds a very dear place in my heart. And I worked closely with Dr. Narayan and with Dr. Nayanatara, and we've been close colleagues since then. So I'm very happy to see familiar faces and also maybe meet some new faces today. So as Dr. Narayan introduced, I'm an associate professor at North Carolina State University, and here's my contact information if anybody has questions after the lecture. And today I'm going to talk about steps of conducting a systematic literature review. I mean, this is a really helpful tool, both for just getting started on projects if you need to understand the background on a given topic, but these are also highly publishable. I've published several systematic literature reviews. So I'm going to take you today through the steps of how we conduct a systematic review. First of all, can everybody sort of hear me okay? Is my pace okay? Can you all see my slides? Is everything on board?
Yes,
Yes,
sir.
madam.
Yes, madam. It's good.
Okay, great. So let's see. So I'll just tell you just a little bit more about kind of who I am and what I do. I'm trained as an environmental engineer and as an epidemiologist. I received my bachelor's from MIT in environmental engineering. I'm from Turkey. I finished high school in Turkey, but then moved to the US for college. And after finishing my bachelor's at MIT, I went to UC Berkeley to get my master's in, again, one more time in environmental engineering, then also in epidemiology and biostatistics, and I finished my PhD there too. And I worked as research scientist at the UC Berkeley School of Public Health for 5 years or so, and I joined the faculty at North Carolina State University in 2019. So that's sort of a brief summary of who I am, and this is a brief summary of what we're going to cover today. Notice that I've been mentioning that we're going to be talking about a systematic review, and you might wonder, how is a systematic review different from a non-systematic review? What do I even mean by that word? What are the steps in conducting a systematic review? And if you do want to take it forward to publication, what are some best practices for publishing a systematic review? So hopefully by the end of today's session, when we come back to these questions, we will have answered them all. So if we think about different types of review, you can see sort of on the right-hand side, I'm showing this Venn diagram where there's all possible reviews, and then systematic reviews are a subset of indicating that they're like a very sort of unique type of review that fall within this broad category. And then within systematic reviews, we also have even smaller subsets called meta-analyses and individual patient data meta-analysis. We're not going to go into those today. We're going to talk about kind of broad methodology for reviews, and then we're gonna hone in specifically on systematic reviews. So when we think about all reviews, when we think about this bigger circle, typically what we have in mind is this traditional or narrative review. That means it's a review article that's addressing typically a broad question. And I'm sure you all are very familiar with research questions and research papers, right? When we write a research paper, there's a structure of background, methods, results, conclusions. When you are reading a traditional or a narrative review, that method section is usually missing, or it can be quite short because it's not a methodological piece. It's really more a broad review where the reviewers relied on their own knowledge of the field to write down their thoughts and their synthesis of the literature. So that also means they're not using a specific search strategy for identifying the literature to review. The pieces that they choose to review may be limited by their own knowledge of the relevant studies. For example, if I want to write a review on 24/7 water supply, and if I want to write a traditional review, maybe I say I don't need a search strategy. I already know off the top of my head maybe 10 studies. So I'm going to synthesize that information, and that's going to be my narrative review. What that means is, though, there's risk of bias from selective citation, right? The 10 studies that I know are these studies that I wrote, or they may be studies that my close colleagues wrote, or they may be studies that I'm familiar with somehow from the literature, but they're not representative of the full literature, right? I'm selecting without telling my readers what kind of rule am I using for selecting these papers. I'm selecting them because they're at the top of my head, right? I know of them. So what that means is two things. A, there could be bias in which studies I may choose to include in my review. But also, if somebody else wants to replicate my review, if someone else wants to review that same topic, they might land a different set of studies because they may know of different authors, they may have different collaborators. In other words, my work is not scientifically reproducible, right? Because the process by which I selected what articles to include in my review, it's not really scientific. It's driven by personal choice. So that's the primary limitation of doing this kind of traditional narrative review. Relying on your own knowledge is not going to be sufficient, and it could be biased. So a systematic review, on the other hand, really just use the prescribed approach, and it's very much scientific methodologically, and therefore it's reproducible. And so those are the major strengths of doing a systematic review. So typically a systematic review, now we're looking at the gray circle within the larger circle, right? Among all reviews, a special subset is considered a systematic review. And if you're doing a systematic review, if I'm going to do one, I'm usually addressing a focused question, a tight focused question. And my paper is going to have a method section where I clearly describe my methods for identifying the articles that I'm going to include. And these are pre-specified. That means pre-specified means even before starting on the review, I've written down exactly what I'm going to do, how I'm going to include studies, how I'm going to find the studies, how I'm going to exclude them, and we don't change these along the way, right? We decide if you want to do a systematic review, these are pre-specified at the onset, and then you stick with them. And then once you have defined your methods, you put them together in your method section, and that means your search strategy is also clearly described, and it's an exhaustive strategy. Exhaustive meaning any paper that's out there that's focusing on 24/7 water supply is going to be caught in your search. Like you want to cast a big net, right? If you do an exhaustive big search, you want to make sure that you catch every study. But it's also transparent, right? Because I've written down exactly how I'm going to find the articles. And when it's transparent, it means that somebody else can reproduce it. They can take the rules that I wrote down, they can follow the same methodology. And the idea is that they're going to land in their hands the exact same set of articles that are going to then be eligible for their review. So it's going to be less prone to bias because if I do a review and Dr. Narayan does a review, we land on the same set of studies that we decide to include in our review because it's not a personal choice. We've written down the rules, how we're going to do it. Yeah, so far so good. Any questions on systematic versus traditional reviews? Which one do you think takes longer and more work?
No, madam, it's good. Good. Go ahead, madam.
Yeah. And which one of these do you think takes more work? And that's I'm curious what the participants think. Has any one of you worked on a systematic review before?
No, madam, no.
No? Okay, so I'll give the answers then, right? But look at the questions I put up, right? If you have worked on a systematic review, or if you're planning to start a systematic review, you might think about how long is this gonna take? How many people is it gonna take to do this? Can I publish this? And is this going to be cited, right? So these are sort of things that you might think about if you are thinking about embarking on a systematic review. So let's pause on these questions for a second. And as we go through the rest of the lecture, we're gonna get at some of these answers. Like, is this how, which one is an easier thing to do, a traditional review or a systematic review? And if you want to do it systematically, what kind of resources do you need to put into it? Yeah, so let's just recap one more time. So when you are doing a systematic review, some of the really important parameters is that it's transparent. So if your readers can judge the quality of your review from reading your method section, it's replicable, right? Readers can arrive at the same results if they replicate your methods from your written description. And it just provides a systematic synthesis of evidence on a given research question. So basically, when you write a systematic review on a topic, that makes you the subject matter expert on that topic because you've really exhaustively just dug up all the evidence on it. That makes the systematic reviews highly publishable. There's a lot of high impact sort of selective journals that do publish systematic reviews. And because it's such an exhaustive piece of work, they tend to be cited a lot. Like it just sort of becomes this is the expert's synthesis, expert's summary on a topic. So when people are looking for something to cite, say on 24/7 water supply, if they find a systematic review, they'll tend to cite that. Right, so they tend to garner a lot of citations, which is good in terms of career building, right? We want to publish, and we want to publish papers that are getting cited. So the downside to all of this is that this is a lot of work. Right, so traditional review might be quite quick because you're thinking of what articles to include in your review off the top of your head, and then you can get to writing, and then in a couple of weeks, maybe you're done. If you're doing a systematic review, in my experience, it takes 1 year from start to finish. From when you have the idea to when you get to a publication stage, it takes approximately 1 year, and typically it takes more than one person. So ideally, we do this using a team, and at a minimum 2 investigators. And we're going to get into why we need at least 2 investigators. Part of it is to split the work, but part of it also is just this idea of doing it in a robust way. But keep these ideas in mind that if you want to do one of these, you better find a partner. It's ideal to do a systematic review using at least 2 investigators. So I've done a few of these in my career, and some of these, so the 2 papers that I've put up here are 2 systematic reviews that I published about 10 years ago in 2014. And you can see that they both got cited quite a bit, right? So one of them got 221 citations, the other one got 172. I just got this off of Google Scholar the other day, right? So you can see if you do these well, if you put together a high quality systematic review, then it certainly is a definitive piece of synthesis on your topic, and it tends to be scientifically well regarded and highly cited. So these are the steps on how to conduct a systematic review. Like this is sort of the recipe, and we're going to follow the different parts of the recipe. So first, you formulate your research question. And that's different from, and we're gonna get into in a second what that means. You have to formulate a tight, specific research question. Then that research question needs to be translated into search terms. Like you've all done a Google Scholar search or just a Google search, right? Like we don't just like write a full sentence into Google. We put a search term, like the best food in Darwad, right? Like you might just put in something like that. So you have a question in mind, but you need to translate that into searchable terms. And then once you have your searchable terms, you do a database search. The database search yields the articles that you're going to review. And the first thing you do is you screen the titles and the abstracts, right? The title of the article and the summary abstract of it. And then whatever gets shortlisted in that stage goes through full text screening. And then after full text screening, you land a smaller number of articles where you extract data. You pull out the data that you're going to use to synthesize the information. And then you take all of that information and you generate your scientific synthesis of it. Yeah. So let's just start with the first one, formulating the research question. What's most important in formulating your research question is that it's as specific as possible. A broad question is going to make it really difficult to conduct a systematic review. You want to be very crisp, you want to be very tight, you want to be very specific in your research question. So systematic reviews, they kind of have the way they started being done was in the field of clinical medicine. So the format for formulating this specific question is typically referred to as the PICO format. And PICO stands for patient, intervention, comparison group, outcome. We all not are medical scientists here, so we don't need to have patients or comparison groups in our systematic reviews. But the idea is that we want to have a multi-part focused research question, right? So if you take the idea of the PICO format and distill it to its basic idea, is that you need to define a focused 4-part, either 3-part or 4-part review question, but it needs to be able to broken down into these specific parts. So for example, I'm going to lead you through a systematic review that one of my PhD students conducted. And I'm going to just sort of walk you through the examples at each step of how did she do all of these different parts of the systematic review. So at the stage of formulating her research question, she's trying to define a focused 4-part question. So she came up with, does wastewater irrigation increase antimicrobial resistance in soil and in groundwater? Right, so wastewater is part 1. Right, what am I worried about? Wastewater. But what are we doing with the wastewater? The mechanism, part 2, is irrigation. What is the outcome? Antimicrobial resistance. That's part 3. Where am I looking for antimicrobial resistance? In soil and in groundwater. That's part 4. Right? So in other words, we can take this sentence and we can break it down. What are the 4 parts of my research question? And you're going to see in a second why that's important. So once you formulate your research question, the first thing we do before we do any more work is to check if a systematic review on that particular research question already exists, right? And if one exists, you want to look at what year it was published. Maybe it was a really old systematic review, maybe it was done 20 years ago. You need to decide, is there a recent review available? Or if the existing review is old, is an update needed? You also want to look at, for this published systematic review that exists on your study question, is it a good one? Is it a high quality review? Are the methods sound? Or is an improvement needed? Right? If an update or an improvement is needed, or if a systematic review on your topic does not exist, then you're good. Then you can proceed. You can take on the work of doing a systematic review. But if a high quality recent review on your topic exists, then it's going to be a wasted effort to try and do a systematic review yourself, right? So at that point, you need to go back to your research question, or in other words, you need to go back one slide, right, and reformulate a different research question, because there is no reason for embarking on a systematic review if a recent high quality review already exists. But assuming that you did your checking and there is no existing review, or maybe there is one, but it needs an update, it needs an improvement, then you proceed. So this is the example that I had given. So this is now we're moving on to the second step of developing your search terms. Right, my research question was, does wastewater irrigation increase antimicrobial resistance in soil and groundwater? And now I'm going to really formally break it down into these different parts, right, into the 4 different columns. And I might think of wastewater as the exposure, irrigation as the mechanism, antimicrobial resistance as the outcome, and soil and groundwater as the setting, right? So these are the 4 pillars of my search. These 4 columns are going to inform how I'm going to search the literature for studies that are tackling this particular research question. But you might imagine, for any one of these words, there's synonyms, right? If I only search for wastewater, I might miss a study that is focused on wastewater, but instead of using the word wastewater, they're using the word sewage, right? Or maybe instead of using the word sewage, they're using the word effluent. They're using the word gray water, right? You might imagine there's many words that are synonymous with wastewater, and different studies might have referred to wastewater using different terminology. So that means if I want to catch every study that's been done on this topic, only searching for the word wastewater is going to give me a very limited number of studies. I really need to expand my search and include all possible words that also refer to wastewater. Yeah, so at this point in the review, we sit down and think about what are some other possible words that people may have used to refer to wastewater? What are some possible words that they may have used to refer to irrigation? What are some synonyms for antimicrobial resistance? What are some synonyms for soil and groundwater? So that then when I'm using these words to form my search strategy, I'm exhaustive, right? I'm not missing a study just because they used a different word to refer to the same thing that they have in mind as me. Right, so in the next step of developing the search terms, we identify synonyms for each of the terms in each column. Right, I gave some examples already. Right, for wastewater, what are some synonyms? A synonym just means, right, it's just another word for the same concept. What are some different ways of saying wastewater? Someone may say sewage, they may say effluent, they may say black water, they may say reclaimed water, right? You want to be creative at this stage and really think about what are all the different ways somebody could be referring to wastewater. And then you do that for every single one of your columns, right? Over here, I'm just showing the exposure column. For the mechanism, for the outcome, for the setting, you can see like the very first step is to come up with this list, right? For irrigation, we thought agriculture might be a synonym. For outcomes, antimicrobial resistant, antibiotic resistant, multi-drug resistant, right? These are all words that mean the same thing. And for the location, for soil versus groundwater, we also want to search for the word field, surface water, aquifer, well water, things like that. Yeah, so once you kind of come up with this list, this is something that you save, right? This is something you really hang on to. You can see over here, right? This is my supplemental table from the paper that we published, because most journals are going to want to see how did you define your search terms. This is going back to that idea of being transparent and reproducible. If somebody else wants to do that same search, they need to be able to see what search term that you used to land the studies that you reviewed. Yeah, so this is something that you save. Once you make this list and you decide on it, you just that table, you just make a PDF out of it and put it aside so that you can include it in your publication as a supplemental table. So the next thing we do once we have our search terms is to search relevant databases for relevant articles. So the rule of thumb is that if you want to do a high quality systematic review, you need to search at least 3 to 4 databases for peer-reviewed literature. So we don't just search 1 or 2, right? Because again, if we search 1 or 2, we might miss some articles, and we really don't want to miss any articles. The rule of thumb is at least 3 or 4. Some of the more commonly used generic ones are PubMed and Web of Science, but there also will be literature-specific, discipline-specific databases that you might choose because they're relevant for your field of study, for your research question, right? So these are a couple of generic ones, but there's also many others out there. The bottom line is that you need to pick 3 or 4 databases that include peer-reviewed literature. And if you want to publish your systematic review, it's also expected that you search at least one database for gray literature, right? So gray literature means things that are not peer-reviewed, that are not published under the peer-reviewed sort of publication rubric, but they're nonetheless contain information that may be relevant for your review. What are some examples of gray literature? Conference proceedings, white papers, people's master's or PhD theses, right, if they have not published them. Sometimes these also include really relevant information. So you need to search at least one database for gray literature as well. And here's an example of a couple of different databases, right? You can see they're broken down by general databases versus subject-specific databases, right? PubMed, Embase, Cochrane Controlled Trials Register. There's really just a variety, and you can sort of, the URLs are provided here, but you also might be familiar with some subject-specific databases, right, that are more relevant to your research question. And certainly you want to do a good job of maybe a couple of general ones, a couple of subject-specific ones, so that you end up with 3 or 4 total databases for peer-reviewed literature. So once we have our search terms, and then once we have and our list of databases we want to search, we are ready to do our database search. Right, recall those columns, right? Remember these columns that we looked at, right? I have 4 different columns here: exposure, mechanism, outcomes, location. And I'm going to do my search separately for each column. right? Within each column, we start by searching for each individual term. Then within the column, you combine all of the terms with an OR operator. Then you repeat that for each of the columns, and then you combine across the terms across the columns with an AND operator. Right, so this is probably sounding a little abstract. So we're just gonna let me show you examples of what that looks like when you actually do it. Right, so this is my student search for that column 1, the first column, that's exposure. Right, so these are all the individual words that she came up with that mean wastewater. And then she searched for each one of these individually, right? So when you search for wastewater in PubMed, you get 108,000 entries, right? So these are the number of entries, number of hits that the search returns for any given search term, right? When you put wastewater into Web of Science, she landed 145,000, right? A different database, CAB Direct, yielded more closer to 7,000 articles for wastewater. And this particular database yielded almost 500,000, right? So these numbers are big. Don't be scared, right? So this is just the first step, right? When I search for wastewater in 4 different databases, what kind of returns do I get? How many articles show up that have the word wastewater in them? Likewise, she did it, right? How many articles come up in these different databases that have the word sewage in them? How many articles come up that have the word effluent in them, right? You can see we're just sort of building our search one term at a time. Wastewater, then sewage, then effluent, all the way down. And then once we have done the individual search for each one of these terms, we get a good idea of which ones of these are commonly used terms, right? I can see the most common ways of referring to wastewater are going to be these top 3. These are returning the most yields. But we are also getting some yields for some of these terms as well. So it was a good thing that we included these, right? Because certainly there are some 10,000 articles that are using the word treated effluent, say instead of wastewater, right? And if we did not have the search term, we would have missed these 10,000 articles. So once you've done the individual search by the individual terms, you combine all of these words with an OR statement, right? Because you want to catch studies that either say wastewater or say sewage or say effluent or say reclaimed wastewater, right? We string these together with an or statement between each one of them. And that just gives us our column 1 search string sort of put together, right? It's all of these terms that have been combined with an or, because we want to capture a study, whether it says wastewater or sewage in the study, right? Either way, we want to capture that particular study. So when we combine all of these terms into one search string with an OR operator, then we can see we're getting some really large number of studies, right? So just there's in the PubMed database, there's 130,000 studies that use any one of these terms. In the Web of Science database, there's 255,000 studies that use any one of these terms, right? And you can just keep following the columns as we go along.
Madam,
And then we do this. Yes, go for it.
that means if you take as a one particular topic, we will find out the public media search and Web of Science and CIB direct search and agriculture environmental science. And based on that, we will looking to the one particular topic, and these are all the area will be covered, madam.
Yes. So you've already picked your topic, right? So now you're trying to find the articles. You're trying to find what articles am I going to include in my review. So that means you need to find out in these. Yeah.
No, my question is how you make it as this 108,198, the number, or Web of Science 145,000. This is the total database, the statistical.
Yeah, so these are the number of studies in these databases that meet these search criteria.
How are we going to find out, madam? How are we going to find out?
How do you find out? So you go into the database, right? You search. So it's just like Web of Science or Google Scholar or PubMed, like they all have their search portals. You just go in and you type in the word wastewater and you hit search. And then it shows you how many entries you have. Like it says this search returned 100,000 papers.
Okay. The left side they are going to find out the numbers. Okay.
Yeah. And the
That's the
database will
point.
tell you. Yeah, when you put in your search term, the database will tell you there's 108,000 articles that contain the search term, right? Like you're getting that information from the database search.
Okay.
Yeah.
Yes, ma'am. Yes.
And then I keep track, right? Like in each particular database, how many eligible articles am I getting from that search, right? And then we just tally up the numbers. And I put a note here, right? These numbers are really large, right? If I told you that you need to review 800,000 articles, then you would say this is not possible, right? Like it's not going to be possible to review all of these articles and systematically synthesize the information. Don't be alarmed by the large number of hits at this stage, right? This is when we were talking about that exhaustive search, right? We want to catch any article that has any one of these terms. But this is only our exposure column, right? We do the same thing for our second column, the mechanism. We search for the word agriculture in all 4 of the databases. We search for the word irrigation in all the 4 databases. Then we combine them with an OR, and then we get a combined search. Now that's returning close to 2 million entries. Right? Then
No, some articles will be going to available freely, but some articles will be going to subscribe. Then how are you going to find out, madam?
That's a little bit later. Yeah, so we're going to talk about that. That's a very good question. Yeah, so we'll talk about, I mean, obviously, you're not going to read all 2 million of these articles, right? So the word agriculture and irrigation come up in 2 million articles, and we're not going to read every single one of them, right? So we'll just get to how do we get from these numbers to a small number of articles to review. But this is, you start big and then you pare down, right? So this, we're still in the big part of it. You do the same thing for the outcomes, right? For the outcome column, do your search, and then you do the same thing for your setting or location column, and just see how many articles contain any one of these words, right? Like the word field, the word soil, etc. Then we combine all of these columns with an and, right? Because it's not sufficient that a paper is only talking about wastewater, right? We want it to be talking about wastewater and irrigation and antimicrobial resistance and soils or groundwater, right? So when we combine things with an and, then now you can see there's only 260 articles in PubMed that meet all of these search criteria. 190 articles in the Web of Science that meet all of these search criteria. In total, right, we have, if we sum up across all of the 4 databases that we've searched, we land close to 4,000 articles that meet all 4 of my columns, right? Each individual column was giving me millions of entries. But if I want to have some search words that meet each of those columns, that really brings the number of hits down, right? Because many studies will contain the terms in one of the columns, but few studies will contain the terms in all 4 of those columns, right? So the numbers of eligible studies drastically goes down in this stage, right? So in this case, we landed close to 4,000 eligible studies that we're going to consider for our review. Right, and then that big search term, when we combined across all 4 columns, it looks something like this, right? You can see we have the individual ores, right? This is my wastewater field, gray water or gray waters or black water or sewage effluent, right? And I've combined it with agriculture and antimicrobial resistance and my fields and groundwater and things like that. This makes your formal search string, right? So when you combine your columns with an and, that gives you the final search string. And this is another thing that we save at this point, right? You can see that this is in our published paper, because most journals will want to see, they require, ultimately, when you combine all of your search terms with the ors and the ands, what is your final search string that resulted from that, so that it's transparent and reproducible. So save it for at least one of the databases that you searched so that you can include it in your publication. So at this stage also in your search, you want to record the number of entries from each database, and you want to record the total number of entries across all databases. But as you know, as there was a question, right? Not all of these studies are going to be available to us as a publication. And you can also imagine when you search multiple databases, there's going to be duplicates, right? Web of Science and PubMed might give you some of the same articles, and those duplicates are currently captured in that total number. So just make note that at some point down the line, we need to remove those duplicates, right? But the first thing that we record is we record how many entries we've gotten from each database from our searches, and we record how many total entries we've gotten across all databases. And that's this table that I showed right here, right? Our ultimate tally. If we're starting out with something like 4,000 articles. So where do we go from there? So the easiest way at this point is to start using a referencing software, Because if you are aiming to review 4,000 studies, doing that manually is going to get really complicated. So at this point, when you've saved your searches from each of these databases, they have an option for exporting all references that you're going to review to a reference software, right? So in other words, those 4,000 articles, close to 4,000 articles that you decided you are eligible, right? They're meeting your search criteria. All of those references need to be exported to a reference software. I don't know if any of you use referencing software. Some of them are free, some of them require subscription, but Mendeley is common. I use Zotero, some people use RevMan. But bottom line, you need software. You need software to make this process manageable. By hand, it will get really complicated. And when you export all of your references into a referencing software, typically most of these software will remove the duplicates automatically, right? So then all of those duplicate entries, if the same study was coming from PubMed and Web of Science, if you export it to something like Mendeley, those duplicates will be automatically reviewed. That means by the time at the end of this step, you have the total number of unique entries across all databases after duplicates are removed, right? These are now unique studies, not replicates, not duplicates, right? These are the unique studies that you've landed. So at this point, you might pause and think, right? How many articles do I have that are eligible for the rest of my review? Like how many of them met my research criteria? And the goal is to, at this stage, to land somewhere between 5,000 to, on the higher end, 10,000 unique articles. Right? If you go through the searching steps and you land a number of articles that meet your search terms, and you end with somewhere in that range between 5,000 and 10,000 articles, you say, I'm good, I'm going to proceed with the rest of my review. If you are not meeting this mark, typically we go back and we revise our research question and we repeat our search, right? If you do go through all of these steps and you've landed less than 3,000 articles, typically that means the scope is too small. Like your study question is too specific. You need to broaden a little bit so that you can catch more studies. If you have caught more than 10,000 studies, typically means that your scope is too large. You need to go back and narrow down your research question, kind of make it a little tighter, a little bit more focused. And then you need to repeat the whole process. You need to repeat the database search and then finalize. And sometimes we iterate a couple of times, right? Maybe you do your first search, you land 20,000 articles and you say, wow, the question was too broad. I'm going to make it a bit more narrow. Maybe you repeat it one more time, you land 15,000 entries. That might still be too much, right? How are you going to review all 15,000? It's going to take a lot of time. Then you might say, my scope is still too broad. I'm going to narrow it down a little bit more. You iterate until you kind of hit the sweet spot. You want to have somewhere between 5,000 and 10,000 articles at this stage, at the database search stage. So once you get there, then we start screening them, right? So say in my student's case, she had close to 4,000 articles to screen. And when we're screening them, we start by screening their titles and abstracts, right? So for these 4,000 articles, we don't read the entire article. As a first cut, we read the title and we read the abstract. And to allow, yes.
Earlier, what we have to do, we take as initially, we fix the research question initially.
Mm-hmm.
And based on that, we will review all the 10,000 articles, and whether it is correct or not correct, based on the review, our review of questions, then we will go for some systematically reviewing. That
Yeah,
means
so
that means first of all, we define our research questions initially, and after that we will deciding the methodology, the tools, what are all the sample size. We will discuss we will take into that is a column wise, and we will put into the what are all the main core areas, right? That will be
Yes.
helpful from the Mandalo and all those things.
Yes. Yeah.
But it takes too much time, madam, actually.
It takes so much time. It takes a lot of time. Yeah. So these things take a year easily. In my experience, from start to finish, it takes a year to do a systematic review, right? So if you want to do a quick review, you don't need to do any of this. But if you want to embark on a systematic review and publish it in a high quality journal, then these are the steps. But keep in mind, you're not going to read all 10,000 studies, right? Like at this stage, you're going to screen their titles and abstracts. That's the first step, right? So in my student's case, right, she had something like 4,000 studies, and she exported them into a referencing software. And then she started screening the titles and the abstracts, right? For each study, let me read the title and let me read the abstract. Because sometimes just from the title or the abstract, it's apparent that the study is not relevant to your search, right? Even though it hit the search terms, it used the word wastewater, but maybe it's just, it's investigating a different aspect of wastewater than the one that you're interested in, right? So you can tell pretty quickly from the titles and the abstracts that some studies are not going to be eligible, right? So to make that decision, whether a study is going to be eligible or not eligible, you write down your inclusion-exclusion criteria, right? You say, I'm going to review the abstracts of all of these, of all 4,000 articles, and I'm going to use my inclusion-exclusion criteria to decide, is this article eligible to proceed into my review or is it ineligible, right? So you might say, we included studies if they detected or quantified antimicrobial resistant bacteria, but we excluded studies that focus on application of biosolids or things like that, right? You decide what are your inclusion versus exclusion criteria, and you need to define them and write them down early in the process because journals require this section, right? I took this directly from the publication that we had to write down what were our pre-specified inclusion exclusion criteria. Then you start scanning, right? You start scanning the titles and abstracts of each article, and you determine if the article meets the inclusion exclusion criteria. Typically, ideally, we do this by 2 independent investigators, right? Both investigators screen each article, and then they discuss and reach consensus if they have discrepancies. But obviously, that's going to double the amount of work, right? This is going to be even more work. Instead of you screening each article, right, if a second person also needs to screen each article, that's going to double the amount of work. So at a minimum, we can have both investigators screening a subset, maybe 10% of the articles together. On that 10% that they both screen, they can discuss and reach consensus. And then you can divide the remaining articles between the 2 investigators and they can independently screen. Yeah, but as we're screening, we're quickly reading the abstract and we're deciding, is this eligible to be included in my review based on my inclusion exclusion criteria, or is this ineligible? Yeah. And as you're doing this, typically, my students have reported that they can screen the abstract for maybe, I think they can do like 50 to 100 articles in an hour. Like that's about the pace of how quickly this goes, right? If you're trying to kind of calculate how much time this is going to take, they tend to do at the onset maybe 50 articles in an hour. And as you keep screening, you get quite fast at it. And then maybe at the higher end, they reach about 100 articles an hour, only reading the title and the abstract, not the full study. Yeah, so, and once again, there are tools to make this process easier. So for example, there's specified systematic review software. One example is Covidence that my students have used a lot and I've used a lot. And that makes this process much easier, right? It just shows the abstract for you and then you vote on it if you use software. And I've included the link here, right? So you guys can go in and see what that looks like. There's a free trial, right? You can see how this software operates, but that makes the screening process a lot easier than trying to print each one of those articles and read them or something, right? I mean, in general, we want to use PDFs. Printing would get really unwieldy, but particularly these types of software also make it really easy to keep track, right? How many articles have already been screened? How many are remaining to be screened? Using software makes it a lot easier to keep it tidy. So what we're doing at this stage is a simple vote on each article. I think there's a question.
This software will uploading all the articles, then it is screening is going on.
Say that again.
For this software regarding
Yes.
the Covidence, earlier slides.
Yes.
This software we are going to uploading all the articles, then it is screening is going on.
Yes. Yeah. So you can export all of the references directly into Covidence, right? So you took them from the databases, you put them into a reference manager, and then from there you can export them directly into Covidence. That means all 4,000 studies that you're intending to screen, they're housed within the Covidence software. And then you vote on them one at a time, one study at a time. You vote yes, no, yes, no, yes, no. Was that your question?
Yes, madam. Yes, madam. Only for reference or the full data, full the overall review of the articles we are going to uploading. The last bibliography will be going to put it or
Yes.
the overall articles.
You're going to upload everything that met your ultimate search, right? So these 4,000 articles in my student's case, right? When she searched across all of these terms, right? And then column 1, column 2, column 3, column 4, then she combined them. And then the combined search gave her 4,000 entries. So those, and this is the combined term, right? This combined term gave her 4,000 entries. And then she uploaded all 4,000 into Covidence. And it's just that you click, right? It's not manual. You say export my references, and then all 4,000 entries are housed within Covidence, including their PDF files, right? So if a PDF file exists for the full study, Covidence pulls that out as well into the software.
At a time, it's possible, madam. 4,000 they are going to uploading.
Yes, no problem. Yeah. Yeah, my colleagues right now are doing it with 10,000 studies. It's not a problem to be uploading 4,000 studies into Covidence. Yeah, that's not a problem.
Yes, madam.
Right, so then at this stage, you're reviewing, yeah, you're voting on each article. Yes, no, right? No means not eligible to be included in my review based on the title or the abstract. And these will be excluded from at this stage, right? You will never come back to these articles. Yes means it's eligible to be included in my review. That means these will move on to full text screening. Maybe means I need to evaluate it further to decide. I can't decide based on the title or the abstract. I need to read the full text, right, to decide if the study is eligible or not, right? So these are the three possible outcomes from this title abstract screening. So the no's will be excluded. The yes and the maybes will be included in the next stage of the review, which is full text screening. Right, therefore, we want to be conservative at this stage, right? It's better to have a lot of yeses and maybes. It's okay to have extra articles shortlisted, but we don't want to miss eligible articles because we don't want to have them mistakenly excluded as no, right? So if you're unsure at this stage, is this a yes or a no? I can't quite tell from the abstract, then mark it as a maybe. Because the yes and the maybes move on to the next stage. They move on to the next stage of full text screening, right? Like when we read the full article. And when you do this, you also record the number of the no's and the yes and maybes. Yeah, so you want to, at each stage, you want to keep track. How many articles have I excluded? How many of them are moving forward to the next stage as a yes and maybe? So then we go to those articles that are shortlisted for the full text screening, we read them in full text using ideally a PDF file. And as we're reading the PDF, just make sure you annotate, you highlight, you take notes, right? Read it actively. And then at that stage, you vote again on each article, right? Because now you have the full information, right? You shortlisted based on the title abstract. Now a small number of articles are being read in full text. And once you have access to the full text, you can make a final decision. No, it's not eligible to be included in my review, right? Those will be excluded. Or yes, this is eligible to be included in my review. And these will move on to the next stage of data extraction. For any article at this stage, in the full text screening stage, any article that you're voting no on, you need to mark the reason why, because the journals will require why you excluded. You don't need to do that in the big screening, the title abstract screening. You don't need to justify why you excluded articles. But in this full text screening, in the subset, shortlisted articles that are going through the full text screening, anytime you vote no, you need to mark the reason why. And then you can group those into major categories. These are the major reasons why I excluded articles. And then you make something called a Prisma chart. And I'm just going to show that in a second because this is something that the journals require. Right, so it looks something like this. And this is why I was telling you along the way, you need to record, you need to write down the number of records. Right, this was the number of records identified through database searching. This was my number, so 4,000-ish here. Number of unique records after duplicates are removed. Number of records where you screened the title and the abstract. How many of them did you exclude? How many of them were shortlisted for full text screening? And of these, how many of them were excluded with the reasons why they were excluded? And then finally at the bottom, then we land at the number of eligible studies that will be included in qualitative synthesis. And then if you choose to do a quantitative synthesis or a meta-analysis, then you can include that as well. So in my student's case, right, so these were some of the numbers, right? You saw this number before. This was what her database search returned, right? 3,798 articles. Then she identified an additional close to 400 from gray literature. And then after duplicates were removed, she had about 3,000 articles in her overall search, right? But of these, she was able to exclude 2,961 based on title abstract screening. That means only 40 articles had to be reviewed in full text. Of these, she decided 15 of them were non-eligible, and she marked the reasons why, right? It did not meet, 6 of them did not meet this criterion, 2 of them did not meet that criterion, 15 were excluded at the full text screening stage. That means 26 articles were ultimately shortlisted for the qualitative synthesis step, right? So do not fear, right? We start with big numbers, but then at this abstract and title screening stage, a lot of them you are able to exclude a lot of them just based on the information that's included in the abstract. Only a somewhat small number of articles are screened in full text, and of those, a smaller number are then eligible to be included. Right, so once we have that super short list, right, those 26 studies that are now my subset that I'm going to review, you want to extract data. That means you want to list ahead of time what data, what information do I want from this paper? Do I want to learn something about the study location, the study design, the findings, other relevant information? You list ahead of time what data you want out of these papers, and you extract all of the information needed for synthesis and interpretation on your research question. Right, so as you're reading the paper, the methods, the results, the findings, you want to pull out what are the relevant pieces that I want to pull out from this paper that's going to be important for me to synthesize the evidence across all of the studies that I'm reviewing. I typically do this in Excel, but Covidence can do this as well, right? So you can continue to work in systematic review software, or you can do it in Excel. And this piece typically is also better done by 2 independent investigators, right? Both
So, madam, Nexa.
Say again?
Nexa. You say something regarding the Excel or
Yeah.
systematic. That's a Nexa or something, I don't know. Which software? Any software is there?
Oh, Excel?
The same thing.
Yeah, Microsoft Excel. Yeah.
Okay.
Yeah. So it's just a spreadsheet, Microsoft Excel spreadsheet. Yeah. Or you can do it within Covidence too. And I'll show you what the Excel sheet looks like. Yeah, so just this data extraction stage ideally is also done by 2 independent investigators. That means both investigators extract data from each article. But if you can't do that, again, you can have both investigators extracting data from a subset of the articles, then discuss and reach consensus and divide the remaining articles between the investigators. But at this stage, it's not a very large number, right? Recall, this was only 26 articles. So the best practice would be to have 2 independent investigators reach each one of those 26 articles and pull out the data that you're interested in. And this is what an Excel sheet might look like, right? This is what an extraction sheet looks like. From each study, you want to extract the author and the year, the title of the article, the location. In this case, we extracted the income level of the country, middle income country, low income country. What was the study location? What was the study design? Right? Well, for our particular case, we're interested in type and treatment of wastewater. This is going to depend on your study area, what information you want to pull out from each study. But each one of these is one study that we're including in our review, right? Here's the top study, the second study, the third one. Each one has been read in full text. And for each one of these, we are making notes on what are the relevant aspects, and we're putting them in this Excel sheet. As you're doing this, you also want to be mindful about assessing the quality of the articles, right? So something that we do is a risk of bias assessment, where you evaluate for each of those 26 studies that I included in my review, are they high quality or are they low quality? And for this, there are some published bias assessment scales, and they're typically discipline specific. So you can use an established scale to decide for each study, give them a mark, basically. This is a high quality study or this is a low quality study, right? This is part of your job as a systematic reviewer to evaluate the quality of the studies as well. And then finally, at the very end, when you land all of this information, you synthesize. You synthesize all the evidence that you've pulled out. And at this point in time, you're going to rely only on the information that you include in your data extraction sheet. We only go back to the original papers if you need to pull out additional information from the paper. In other words, when you're putting this Excel sheet together, you want to do a good job, right? You want to pull out all the relevant information so that when it's time to synthesize, you don't need to go back and read each individual article one more time. You can work off of the information that you've already captured in your data extraction sheet, right? And then synthesis can be either qualitative or quantitative. If it's qualitative, you compare and contrast your findings. If you want to do a quantitative synthesis, there's additional tools for a meta-analysis or meta-regression. These are too long for us to go into today, but only if you want to do a quantitative synthesis. And then you interpret the findings. Based on these 26 articles that I've identified and reviewed, what are my recommendations for policy and implementation? What are my recommendations for remaining knowledge gaps for future research? And all of this information for publications, you can summarize all of that in a table, right? Or you can summarize additional details for supplemental information. These are, again, examples from my publications. And then when you are going to publish, this is one good resource to keep in mind, is this Prisma article that has guidelines for how you want to report findings from a systematic review, right? Preferred reporting items for systematic reviews and meta-analysis, or the Prisma statement. If you follow this paper that has specific guidelines for how you need to write up your systematic review so that it is a high quality review that's publishable, right? What are the types of information that I need to write in my paper so that it becomes a high quality systematic review? And you can see this reference that I gave you has a 27 item checklist to describe all components of your review, and journals will typically require this, right? And you can see what that checklist entails over here. That means when you're writing your paper, you want to be seeing what is the requirement for title. Oh, in the title, I need to identify the report as a systematic review or a meta-analysis or both. In other words, my title needs to indicate, my paper title needs to indicate that this was a systematic review. What am I expected to put in the abstract? Just here the instructions for writing the abstract for a systematic review. What do I need to include in my introduction? What do I need to include in my method section? And if you want to write up your systematic review for publication, this is a really good resource. You can just follow and this is freely available online, right? So you can follow the guidelines in this paper for how you write up a systematic review for publications. And when you do that, then typically you land a high quality publication. And as you can see, they tend to get cited quite a bit. So I'm going to stop right here. I think we're just right on time, but I'm also happy to stay and take if there's any additional questions.
Participants, do you have any questions? Durgappa sir? If you have any questions also, you can email Ayse for any clarifications.
And I can share the slides too if they're helpful.
Yes, madam, it's helpful, madam.
Yeah, I'll email the slides so you can access the references. Yeah.
Yes, madam. Thank you very much.
Ma'am, I have a small doubt.
Okay, please.
So, ma'am, how do we ensure that your systematic review is comprehensive and unbiased?
Yeah, so that's just that's a very important question. That's a very good question. That's probably the most important element of doing a systematic review, is to do it transparently, right? So this business here, defining your search terms and writing them down. You want to make sure that you have a focused question, and then you want to make it searchable, and you want to make your search transparent, right? So take your research question and try and break it down. Try and break it down into its individual parts, and then make sure for each part, have you thought of all the different words that a different researcher may have used to refer to the same concept in their study, right? If you do this part well, then, I mean, this is make or break, right? If you don't do this part well, then later it's hard to fix. You need to think through what are all the different words that capture my research question? And then also just search multiple databases, right, for each one of these terms. So just one database would not be exhaustive. You want to search multiple. Right here, we search 4 different databases. And then you want to systematically capture all of this information. So if someone comes back and says, well, did you search for this word? Which database did you search for? What did you get? So you have an answer, right? If someone criticizes your methods, everything is written down. And I can say, yes, I did indeed search for all of these words, and I got this many entries, right? And I think another important thing is to write down what your inclusion exclusion criteria are, right? This needs to be very transparent, right? You don't want to willy-nilly decide, oh, this article, yes, this article, no. You need to be able to justify for each article. Why is this a yes? Why is this a no? Why am I picking this to review? Why was this excluded? If you write all of this down in a transparent way, you're good.
Ma'am, another one doubt. Please clarify what is gray literature? Gray literature.
Yeah, very good question. So gray literature refers to, let's just see if I have I can find it. Anyway, so gray literature means things that are not peer reviewed, right? So typically when we publish, we go through the peer review process, right, in a journal, and that's peer reviewed literature. But there's also a lot of literature that is available on the internet, but has not gone through peer review, right? For example, if my PhD thesis, if you search for it on the internet, you can find it, right? But it's not, my committee members have read it, but it has not gone through scientific peer review. But it can still be a resource if it contains a well-conducted study, right? Or sometimes people write papers for conferences, right? Conference proceedings, they tend to be not peer reviewed, but they can still contain relevant information. So in this effort to be exhaustive, you don't want to focus only on peer-reviewed published literature. You want to include things like conference proceedings, theses, things like that. Because later on, you're going to do a quality assessment, right? You're going to decide anyway for each study that you include, is it a high quality study? Is it a low quality study? So you want to be inclusive at the onset and include gray literature as well. And gray literature, really, what it means is non-peer reviewed. Like that's the best, the definition for gray literature is non-peer reviewed literature.
And
Madam,
then
what
how
about
can,
plagiarism, madam? What about
sir,
plagiarism?
one second, sir. I mean, then how can gray literature be effectively incorporated into a systematic review?
So there are other databases for searching gray literature, right? For example, in this particular case, right, and for my student, this was peer reviewed. Peer reviewed literature returned about 4,000 entries. And then when she searched gray literature, I mean, I think if you just go into Google Scholar and just Google and search for databases for gray literature, it's going to be, again, discipline specific. Like she used a specific database called science.gov, right? In her particular case, it was a governmental database that also included theses and things like that. But you would need to search for your discipline, what is a good database for gray literature? And then search that as an additional search, in addition to your peer-reviewed search.
Are there any ethical concern, ma'am, when we using gray literature, such as unpublished reports or any other works?
I mean, it's actually encouraged because sometimes we worry about publication bias, right? Sometimes, if people have really big findings, those things tend to get published. But if you don't have big findings, somebody might say, I'm not going to bother publishing this report because I didn't find anything exciting, right? So sometimes when you only focus on publications, you might miss really important work that's done but not published. So I think, but you're making a good point, right? You're saying, how am I going to make sure that the gray literature is high quality, right? Is that your question, right? If I include gray literature, how do I make sure that it meets the quality requirements of being a sound study? And you can use things like this, right? There are tools for assessing the quality of the studies, and you're going to be doing that anyway for each study that you include. Right, you're gonna use published tools. For example, one published tool is the Newcastle Ottawa scale, and that's an itemized list for determining the quality of a scientific study. Right, so if you decide that you found something from a gray literature, but it meets these criteria for a high quality scientific work, then it's absolutely fine to include it, right? But if you find that it has low quality based on your quality assessment, then you may choose to exclude it from your review, or at least state that some of the, right, like the gray literature gave you low quality publications, therefore maybe you chose to exclude them.
Ma'am, in India, we have some banned publications which was published. Can we give a reference or mention in our research area or in our research paper? Is it a ethical concern then? When we mention a banned
Cloned journal. In the same name, some international good journals are there. In the same name, these local people are publishing. If we quote those papers, madam, means some of the things which is not great. That same ISBN number, everything they use and then publish in locally, and then they put the name of for development report kind of thing. Some clone journals are there. They are the paid journals. If
I see.
content is, the article is good, madam. If somebody has unknowingly or knowingly published,
Sure.
and then if that content is good, whether we have to use that or not, it is maybe his question, madam.
I see. I mean, if the content, I mean, that's a whole other, yeah, that's a whole other consideration. If the content is good, then you would be obligated to include it. But I think if you have reason to think, I mean, there are some journals, and I think there are rankings of journals online, right? Like there are predatory journals where you pay and they publish, or sometimes like some journals have a reputation for people put in fake articles, they take in someone else's name. I think it would be important to use a published source for differentiating what journals are predatory, and then exclude articles that come from those journals. Yeah, that's a good question.
Thank you, ma'am.
What about plagiarism, madam?
Can you say that again?
Plagiarism.
Same thing. I mean, I think it's hard for you as the reviewer to judge if an individual study has plagiarism in it or not, right? I mean, how are you supposed to know? I mean, if somebody has stolen somebody else's work, that's on the editor of the journal to figure that out before it's published. So I think the best thing you can do is to rely on the journal's reputation and the journal's ranking. I think some journals are known for rigorous peer review, and some journals are known for, they're like, it's peer reviewed, but it's a very sort of, it's not real. And there's a lot of funny stuff going on. And I would reference an online ranking, an online sort of quality assessment of journals to decide what journals to exclude. But I think I think it'd be hard to decide individually if any one given article has been plagiarized or not. I think you need to rely on the editor and you need to rely on the peer review.
Thank you, madam. Thank you.
Any questions from the participants?
Ma'am, what is a bias assessment scale, ma'am? Can you please explain?
Talk little loudly.
Hello. What is a bias assessment scale, ma'am? Can you please explain about it?
Yeah, so you can look up the study, right? You can search for the study online too to sort of see what that looks like. It's just an itemized tool for assessing the quality of each study, right? It's just basically a checklist, an itemized checklist for how did the study handle this particular thing? Did they clearly describe their methods? Is there bias in their enrollment criteria, right? So you basically following this particular checklist, you can assign a score to each article that you review to determine if it's a high quality article or a low quality article, right? Because there will be in the checklist, there will be some examples of, right, just certain things need to be done a certain way for it to be high quality science. And then the scale, this published scale, lets you assign a score based on how well that's been done, right? If it's partially done, you give a low score. If it's fully done, you give a high score. And then you can sum up the scores across the full checklist. And then each study in your review gets a score for its quality, right? And then you can say, among the 26 articles that I included in my review, 6 were high quality, right? 10 were medium quality, 10 were low quality. And that lets you then summarize the literature, right? You give your readers an assessment of, is there much high quality literature out there on this research question?
Okay, thank you.
Okay, madam. One request, madam.
Yes.
Okay, madam. That you please send any articles, madam, which you have done, so that we'll
Yes.
see this one slides, and again we'll go and read the same thing, so that it will be more useful, madam.
Yes.
The
So I
systematic.
think, yeah, absolutely, absolutely. I think I will share this article, the bias assessment article. I can share this Prisma statement, because these are the guidelines for how we go through the steps of a systematic review. And I'll share a couple of other important resources too. I'm happy to email them out.
Okay. Okay, madam. Then I think it is morning or evening. I don't know, madam.
It's my morning. Yes.
In our case, it is evening, madam.
Yes.
I take this opportunity to thank you, Dr. Ayse Ercumen, for giving a wonderful and valuable presentation on systematic review of literature and then how to publish. It's really wonderful, madam. You have started with the thing how we have to search, and then how we have to reduce this one, how we have to give the prompts, means how we have to take this one based on our objectives or whatever our research, this one, madam, how we have to increase the number of options so that we can reduce the number of articles, and systematically we get into some systematic review and then publish it. This is review it and publish it, madam. Thank you very much, madam. If you share your article, so that we link this and then that with our work, so that we'll definitely increase our quality of research, madam. On behalf of CMDR, on behalf of participants, on my own behalf, madam, I wholeheartedly take this opportunity to thank you, madam. Thanks a lot, madam. So
Yeah, thank you.
yes, madam. We'll have a group photo, madam, in the
Okay.
here only, madam.
Okay.
So that,
Yeah.
yes, madam. You have to stop your sharing, madam, so that.
Okay, sure. That I see. Sure.
Yes, madam. Good screen. Smile, please. One second, madam. One second. I think some have not switched on their this one. Thank you, madam. Thanks a lot, madam.
Thank you very much. Thanks for participating and for the good questions. I hope at least one person publishes a systematic review based on this.
Definitely, madam. Many will publish, madam. Definitely.
Good luck. Good
Okay.
luck.
Thank you, madam. Thank you.
Bye-bye.
Thank you, madam. Thank you.
Bye.
Thank you, Ayse.
Yeah. Bye.
ಓಕೆ ಹೊರಟು ಬಿಟ್ರಿ ತಡ್ರಿ ಎಲ್ಲ ಅದು ಭಯಂಕರ ಸಿಸ್ಟಮೆಟಿಕ್ ಹೇಳಿದ್ರಿ ಅವ್ರು